I recently watched the video entitled Evolution and Faith by Don Exodus, and it reminded me of an essay by Isaac Asimov. I'll link to his full text in the sidebar. Asimov, as many of you know, was a great writer of fiction and non-fiction, science and science fiction. He was a pioneer of the imagination, and the spark that started roaring fires in the imaginations of a lot of current scientists. He was one of my great inspirations and a champion of reason, logic, and skepticism. His argument concerns the response he received from a comment he made in one of his articles on the advancing knowledge of science, how much we know about the universe that the ancient humans did not. He received a letter from a non-scientist, an English Lit major, who wanted to correct his attitude about science. I'll quote him. The young specialist in English Lit, having quoted me, went on to lecture me severely on the fact that in every century people have thought they understood the universe at last, and in every century they were proved to be wrong. It follows that the one thing we can say about our modern knowledge is that it is wrong. My answer to him was, John, when people thought the earth was flat, they were wrong. When people thought the earth was spherical, they were wrong. But if you think that thinking the earth is spherical is just as wrong as thinking the earth is flat, then your view is wronger than both of them put together. The basic trouble, you see, is that people think that right and wrong are absolute, that everything that isn't perfectly and completely right is totally and equally wrong. However, I don't think that's so. It seems to me that right and wrong are fuzzy concepts, and I will devote this essay to an explanation of why I think so. End quote. For the sake of space, I'm going to condense most of his beautifully worded argument and paraphrase. Once people believed the earth was flat, and they were wrong. But they were also very nearly right. The curvature of a flat surface is 0, and the curvature of the Earth's surface is very nearly 0, to a certain level of approximation, the kind of measurements the ancients were capable of. After some rather brilliant observation by great scientists such as Aristotle, the basic idea of a spherical Earth was advanced, and measured a century later by the Greek philosopher Eratosthenes, by noting the difference in shadow lengths at different latitudes. We thought then that the Earth was a sphere, and that the actual curvature of the Earth must be 0.000126 per mile, a quantity very close to, but not quite equal to 0. This difference was important in our ability to make accurate maps and sail great distances without missing our destination. So, then we thought the Earth was a sphere, but that was also wrong. Based on observations of the other planets, Newton showed that rotating masses are very slightly flattened at the poles. Scientists measuring the Earth very precisely, using newer instruments, were able to determine the degree of oblateness, the measure of departure from a true sphere. If the Earth were a true sphere, it would have a curvature of 8 inches to the mile, but the actual curvature varied from 7.973 inches to 8.027 inches to the mile. The correction in going from spherical to oblate spheroidal is much smaller than going from flat to spherical. Therefore, although the notion of the Earth as a sphere is wrong, strictly speaking, it is not as wrong as the notion that the Earth is flat. Even the oblate spheroidal notion of the Earth is wrong, strictly speaking. In 1958, when the satellite Vanguard 1 was put into orbit about the Earth, it was able to measure the local gravitational pull of the Earth, and therefore its shape, with unprecedented precision. It turned out that the equatorial bulge south of the equator was slightly bulgier than the bulge north of the equator. There seemed no other way of describing this than by saying the Earth was pear-shaped. And at once many people decided that the Earth was nothing like a sphere, but was shaped like a Bartlett pear dangling in space. Actually, the pear-like deviation from oblate spheroid perfect was a matter of yards rather than miles, and the adjustment of curvature was in the millionths of an inch per mile. In short, my English Lit friend, living in a mental world of absolute rights and wrongs, may be imagining that because all theories are wrong, the Earth may be thought spherical now, but cubical next century, and a hollow icosahedron the next, and a donut shape the one after. What actually happens is that once scientists get hold of a good concept, they gradually refine and extend it with greater and greater subtlety, as their instruments of measurement improve. Theories are not so much wrong as incomplete. This can be pointed out in many cases other than just the shape of the Earth. Even when a new theory seems to represent a revolution, it usually arises out of small refinements. If something more than a small refinement were needed, then the old theory would never have endured. Copernicus switched from an Earth-centered planetary system to a Sun-centered one. In doing so, he switched from something that was obvious to something that was apparently ridiculous. However, it was a matter of finding better ways of calculating the motions of the planets in the sky, and eventually the geocentric theory was just left behind. It was precisely because the old theory gave results that were fairly good by the measurement standards of the time that kept it in being so long. Again, it is because the geological formations of the Earth change so slowly, and the living things upon it evolve so slowly, that it seemed reasonable at first to suppose that there was no change, and that the Earth and life always existed as they do today. If that were so, it would make no difference whether the Earth and life were billions of years old or thousands. Thousands were easier to grasp. But when careful observation showed that the Earth and life were changing at a rate that was very tiny but not zero, then it became clear that the Earth and life had to be very old. Modern geology came into being, and so did the notion of biological evolution. If the rate of change were more rapid, geology and evolution would have reached their modern state in ancient times. It is only because the difference between the rate of change in a static universe and the rate of change in an evolutionary one is that between zero and very nearly zero that the creationists can continue propagating their folly. Since the refinements in theory grow smaller and smaller, even quite ancient theories must have been sufficiently right to allow advances to be made, advances that were not wiped out by subsequent refinements. Naturally, the theories we now have might be considered wrong in the simplistic sense of my English Lit correspondent, but in a much truer and subtler sense, they need only be considered incomplete. Thanks for watching.